All right. Hello, everyone. Kia ora and welcome to the 2025 University of Auckland and hear a little bit about what Women in Engineering does as a network. So we'll get right into it. My name is Nashira. I'm currently a penultimate year civil engineering student and I work in the transport sector. And this is Sasha.
Hey guys, so I'm a part 2 Mechatronics engineering student. And yeah, it's just really cool to be emceeing this event because I came to this event when I was in high school, so it's a real full circle moment.
Awesome. So for tonight's program, we'll start off with a bit of an introduction to WEN and what WEN does as a network, and then we'll go into what is engineering and all the different facets of engineering, and then we'll lead into our engineering specialisations, where we'll then get to hear from our lovely speakers down here from all the different specialisations, so you guys can get a bit of a taster for what each spec does here at University of Auckland. And then we'll finish off with a Q&A panel that we'll soon put a link up for. So if you have any questions that come up throughout tonight's session, feel free to just drop a question into the link and we'll hopefully be able to answer as many of them as possible tonight.
So what is WEN? There's 3 things that WEN focuses on. We focus on getting girls into engineering. So the girls like yourself, and we also do high school outreach. We also encourage the girls while they're studying here at the University of Auckland, and we throw a bunch of fun events. Here are some photos, very, very fun. It's great to make new friends, and you really feel like you have a great community when you're in uni. And we also ensure success after we've graduated. So we keep our networks and we make sure, women in STEM, we're all succeeding after we graduate and we're in the workforce. So engineering, at the end of the day, it's problem solving. It's applying the technical skills that you've learned in school and university, whether it be your maths or your physics, to solve real life problems. And engineering is everywhere where you see. It's the devices that you use every day. It's the buildings that you see. So it's such a versatile degree. And obviously I'm biased because I take engineering, but it truly is a really rewarding degree.
All right, so now we have a little bit of a scenario going on. So we've got a friend dancing off a cliff. And does anyone have any ideas of how we're going to save them? Feel free to shout any ideas out. Go on, our lovely engineers down the front. Any ideas? Pull them up. That's a good one. Thank you, Mio. Any other ones from our lovely high school students? Go on, Arushi, give us a solution. Yeah, how are we going to save them as an engineer? Throw a rope down, all good stuff. A big one that we've also had in the past is just building a fence so people don't fall down in the first place. So I think that kind of encapsulates what the core of engineering really is. So obviously all different professions are integral to what we do in the world and society to make the world a better place essentially. But what engineers do that's really special is that we tackle issues at the root cause before they happen. So we try to prevent things before you need someone like a nurse or a doctor to come and help someone. So that's kind of what engineering is all about, and hopefully through our speakers tonight you'll get to hear about all the different ways you can apply problem solving to help people through engineering. Awesome. So at the University of Auckland we have 10 engineering specialisations in total, which is more than many other universities across New Zealand offer. So I won't go too far into each of them because our speakers tonight will explain each of those to you tonight. But if you have any questions that come up, please just feel free to pop them in the slider that will be coming up. So that's the slider over there. We'll give you guys a quick couple of minutes if you want to get that open and then have that ready as you need.
I recommend taking a photo of it so then you always have it with you during the event.
All right, so hopefully everyone's got a photo, but if any other questions come up, you're also welcome to speak to us after. All right, to get us started off, we have our very first speaker who specialises in computer systems, electrical and software engineering.
Awesome. Hi everyone, my name is Dia and I'm a third year computer systems engineering student at the University of Auckland. I grew up in Hamilton and I moved to Auckland for uni. Some of my interests are baking, cooking, hiking and travelling. So a few years ago, I was in the same situation as many of you are, trying to figure out, what's the big next step, what am I going to do with the rest of my life kind of situation. So I totally get where you are. I was someone in high school who was really people orientated, and I wanted to do something in my future which involves directly impacting someone and changing people's lives. So initially, I pursued something along the lines of a clinical pathway. I wanted to explore, a medical career pathway. And then when I did that, I realized actually I want to be able to use my problem-solving ability, my ability to work with people, collaborate, and my curiosity into building real-world solutions that will impact people. I chose computer systems engineering. And in high school, I took math, calculus, physics, English, biochemistry, and computer science. Just a little background for you. So, what is computer systems engineering? So, the kind of most simple way to put it is it's a beautiful blend of software and electrical engineering. So it combines software skills and hardware skills, and it kind of allows you to really work and use your problem-solving abilities to build systems. So we work on systems that make smart devices, right? So you know how your phone unlocks with your face, or Tesla's cars can drive themselves, or even your washing machine knows how heavy your load is. That's all computer systems engineering. We study things such as embedded systems, which is like the brain, or the inside of like a smartwatch or a robot. We do software design, which is building apps or code that controls machines. We do hardware and computer architecture, which is understanding what's inside the device. And we also do AI and machine learning, which is teaching computers how to learn from data. So it's not just about writing code, it's about building an entire system that can interact with the real world. So one of the main things we do as computer systems engineering is we use these technical skills in electrical and software, and we basically learn to communicate it with the real world. So now I'm going to talk about my experience at uni and some of the projects I've done, and hopefully that can give you a bit more insight on computer systems. So in second year, which is when you go into your spec, the first sem you do a lot of theory. So you do the same kind of papers as an electrical student will also do, which is a lot of electronics, basic electrical stuff, coding papers, and you really build a strong foundation. And then end of that, you start your projects. So one of the first projects we did is a smart energy monitoring system, which uses those foundations in electrical and electronics, and also some coding skills, and you get to design your first kind of real-world project. And then this year, we really got into the nitty-gritty, and it was really fun because you can really see what you start to do. So in Sem 1, we did an AI-powered sign language interpreter. So we learnt machine learning, and we used those skills and basically built a software tool that uses computer vision and can read and interpret sign language. So it was a tool that could help the deaf community. Then we also did a Flappy Bird game. So as you can see in the picture there, we used VHDL, which is a hardware description language, and it programs a board called an FPGA, and it displays the game. So you get to design a Flappy Bird game, which is really cool. And then this SEM, we're working on a robot that finds its own path. So again, using a PCB, which you can see over there, we use our electrical and electronic skills, we use our coding skills, we design it, and you work in teams, which is also really fun. So you get to learn from other people, apply your skills, and really kind of, you develop a whole lot of skills with these projects. And you get to be creative as well. You know, there's not kind of like, you have to do it like this. You really get to think outside the box and apply all your knowledge that you've learned so far. So along the way, we've learnt theory, like I said, in electronics, but we also learn about networks, cybersecurity, machine learning, and more. But it's not just all about theory. You get to get your hands dirty and build things, break things, and fix them. So what can you do with computer systems engineering? You can become an embedded systems engineer, an AI or machine learning engineer, a software developer, hardware developer, firmware engineer, cybersecurity specialist. But right now that might just sound like a whole lot of blabber to you. But in the big aspect of things, you could work in any area you like with CompSys, and that's one of the reasons I took it. It's very flexible, and you can kind of go into any industry you like because you have those skills to kind of pick and choose where you go. You could go into space tech, biotech, automation, literally your choice, but you have the skills to transfer, which is the most important thing. So I've put some companies on the side here which a lot of CompSys engineering students have gone on to work from the kind of engineers that I mentioned, the type of engineers that I mentioned before. And those are kind of the big tech companies which you would have seen as well. And you can really pick what you work in. So, you know, you could work at Fisher & Paykel Healthcare and go into the healthcare side of things. Or you could go into Apple and Google and work on the more tech side of things. So the choice is really yours. So if you're someone who is curious, who likes to innovate, who likes to design, think outside the box, and really have a good time and fun time to work on things and different projects, then I think CompSys is for you. You get to be creative, innovative, and solve real-world problems and help people out. So computer systems might be the one for you, and thank you.
Awesome. Next up, we have a speaker from electrical engineering.
Okay. Hi guys, I'm Zoe. I'm in my final year of electrical and electronics engineering. Just a little bit about me. I like trying new recipes, especially sweet treats, mostly because I like eating them, and I also enjoy crochet. So a little while ago, I was also in your position, and I remember thinking to myself, I don't really know what I want to do. All I knew is that I really liked learning how things worked, and I tend to be pretty curious in that area, which led me basically to, do I want to go into science or do I want to go into engineering? So what I ended up kind of discovering was that in science, you learn about the rules that govern the world, and you try and discover new rules, right? So you'll end up being really specialized in one area, and you'll learn more and more about it. But in engineering, you apply those rules to a whole big variety of problems. And to me, who was really scared of ending up kind of stuck in one thing, that appealed to me a lot more because I knew I would have a lot more flexibility in what I wanted to do going forward. So that led me into engineering. And then from there, in your first year, you get to do a little bit of each specialization. And I was wondering, okay, what type of engineering do I do now? That, in our first year, we did a course, a little sampler of electronics, and I really enjoyed how, to me, it felt like a puzzle game, where each level you get new skills and get to solve harder and harder challenges as you go. To me, electrical felt a little bit like that. Each time you approach a problem, you have to look at the tools that you have and figure out how to apply it in a new way. A couple other things that made me feel like electronics and electrical could maybe be it for me was there are a lot of options and electives. It's a really, really wide field, so you can do a lot of different things. You don't have to worry about getting bored or getting stuck with one or the other. It also has probably some of the most hands-on projects in the entire engineering, dare I say. You get to do a lot of actual building of things, a lot of actual experimenting with things, and to me that sounded really interesting because I wanted to be able to have hands-on experience during my degree. Cool, so I've yapped a lot, but now let's actually talk about what is in electrical and electronics engineering. So the kind of main difference is electrical is kind of all the big things you can think of. That's like how you generate power, how the power gets to your home, also things like telecommunications and radio, how your phone gets signal. All that sort of stuff comes under electrical. And then on the other side, you have electronics. So that's slightly smaller scale, things like wireless charging, robotics, medical devices, like the power things in the doors, this projector, all of that sort of stuff comes under electrical engineering. So, I don't know if that's interesting to you, but basically everywhere you look, you can find something electrical. So if you like learning about how things work and you want to be able to apply it anywhere, electrical is a really good place to start. Now I'll just yap a little bit about the sort of things I've gotten to do while I am in my degree and some of the things you'll get to do if you also go into electrical. So on the side here, we have a little project we did in our third year. Basically, it's a water volume sensor for a water tank, but as opposed to just sending a message via a wire, which is the usual way, they decided to make it a little more challenging, and it actually transmits via light. So you can sort of see the two parts are separated a little bit. Unfortunately, our one didn't work very well, so it only had a distance of like 5 centimeters. But if you do it, you could do like a whole meter distance. You'll do better than me. Then we also got to do things like design a wirelessly charging electric car. So if you can see the little blue PCB and the little car, essentially what you do is you electrify the racetrack, and as the car goes over certain areas of the track, it charges and starts to go faster. So that was probably one of the most exciting projects because you got to apply a lot of different things and actually race the cars at the end, which was pretty fun. We came 5th, bit sad, but it's okay. And then the final things are some things I worked on during my internship. So I've had 2 internships in quite different areas. One was in a power company. So that was a lot about distribution, how the power gets from the big dams and whatnot to your house, did a lot of that sort of stuff. And then in my second internship, I worked at Fisher & Paykel Healthcare, which was much more focused on medical devices, as you may know. So I did a lot of testing around making sure medical devices are as safe as they can be and that no one gets electrocuted and that sort of stuff. So you can do quite a variety of things. I've done so much even just in my not very many 4 years. So you can do pretty much anything you can think of. Electronics will offer it here. And it's a really great opportunity if you're curious about how the world works, you like solving problems, and you just want to know a little bit more. So do electrical. Thank you.
Thank you so much. We will have our software engineer next up, Arushi.
Hey guys, so good to see you. I recognize a few faces from Open Day, so it's great to see you guys back. My name's Arushi. I am a final year software engineering student at the University of Auckland, and a bit about me. So I basically, when I left high school, a lot of my friends were going down the law and the clinical pathways, and I was still completely unsure about what I wanted to do. And then I came to university, and I chose to do the clinical pathway at the time. And first year in, I was like, oh, this isn't what I envisioned it to be. And then at the end of my first year, I took a bit of a gamble, and I did engineering. And it was one of those things where, you know, when you always hear, oh, engineering's like this, or medicine is like this, or law's like this, you never really know until you try it, right? Like, you never know how something is. So for me, it was more of that whole learning curve of figuring out what worked for me and what really fit the bill for me. I've just realized I've bypassed all my hobbies, but those are it. And so reflecting back on like what I learnt in my immediate first year of engineering and thereafter, like my favorite parts about engineering and why I love it is the problem solving aspect of it and the autonomy to solve problems the way you want to do that. So having that creative freedom is so important, but so exciting. And then also the autonomy and freedom of like having your day to yourself. A lot of engineering is like you figuring out issues at your pace whilst being in all these meetings and collaborating with all these people, but you get to own your day, and I think that is like what's so exciting about it. And engineering is just it's an open field. Like there's so much scope to what you can do. Like we've got 10 specialisations, software is one of those 10. And even within software, there is so much you can do, which is why it's so exciting. So a bit about why I chose software engineering. So software engineering, for context, is just about building things. So that could be apps, it could be games, it could be websites, and those can be about pretty much anything. Like the website could be about like a restaurant website. It could be a game powered by AI where you're trying to escape some sort of room that you're trapped in. That was something that we made in second year, which was cool. It could be something a bit more serious. It could be learning how to use AI the right way. So that's a bit about software engineering. And for example, your TikTok algorithm, the algorithm that finds all the things that you're interested in, that's software. And that similarly goes for so much of the social media platforms and the things that you intangibly see around you. So moving on to exactly what the career options when you go down software engineering are. That is just a short summary of some of the many careers that you can go down. The best thing about software is that because we live in such a digital age, you become so equipped to go into so many different types of careers. And I think that is what is the most useful part of it, is that you're so aware of the current climate and the things that are going around you in such a low-level way that you become a really big asset to employers when you go out after university. So just like going through some of the words that are up there. Backend is like about databases and finding ways to store things, finding ways to test things as well, making sure that what you're building actually works for yourself and the users that you're wanting that for. Front end is everything you see on your apps. So like even your UI, like this is all front end in the way things look on your phone. Full stack is both of them. Product is like less technical, it's more focused on like actual things you're rolling out and how to manage that and what you want inside that, and a bit more creative in terms of deciding what that might look like. Cybersecurity, obviously we put in so much information online, so knowing how to make sure it's protected and that people aren't getting hold of it when they're not meant to. Site reliability, machine learning and AI. I mean, everyone knows about ChatGPT, right? Copilot, Claude, there are so many different AI platforms, and that's just something that we have to live with. So learning how to live with that, how to use it, how to program it, there are so many parts to that. Cloud engineering, so infrastructure, which is a really big word. I don't even know what that means just yet, but it's a big word, and so that must be pretty smart. Test engineering, so making sure everything that we're actually doing is working and that it's working for us, the people that we want it to work for, and it's actually pretty fun. Test engineering is very fun. And consultancy. Now, I left that as a really broad term, so software engineers have like the absolute privilege of going into software consultancies and being in certain roles where they're not hardcore coding but advising more so, but also moving into bigger consultancies across the world where they're in just an advising position because they have such a unique way and low-level way of understanding problems around us that people are actually facing. And that does not limit itself to just software-specific consultancies. That can be in construction, it can be in general like business consultancies, and that kind of links into companies and jobs. So these are actually based off people that I've met and people that I know that have actually gone into jobs or have jobs lined up at those places. Consulting, so you've got your general EY, PwC, MBB, which you've got McKinsey, BCG, Bain, those are really big companies, really high-tier companies. Investment banking, software engineering roles, banking roles, there are so many different roles there. Big tech, so you've got Atlassian, you've got Google, you've got Facebook, you have a lot of big roles there. SMEs, that is pretty much any software firm, small, medium, and startups. We have a lot of grads going into startups right now, and it's a really exciting space to be in because the movement is so big. And fintechs. Fintechs is also a really cool space to be in. And it's just, all of it is really up and coming, and that's what's so exciting about software. And a bit about my journey. So I have a serious side and a non-serious side. So the serious side is, so I'm in my 3rd year of my software engineering specialisation at the moment, and I don't work crazy hours, I don't work overtime, I just do my normal uni work and then my internship in the summer. And those are all the exciting companies that I've had the chance to be a part of, go and visit them, get to know them, go and intern with, and they've done like some amazing work. So I interned at an Australian company over the summer. I spent 3 months in Sydney, and I'm going back in February, and I met so many amazing people, and the job itself was so rewarding. You walk away from the room and you're like, wow, like I've met some really intelligent people who I really hope that I would be on their level someday. And I think that level of inspiring is a really hard level to like achieve, but it was amazing. And 2 of the other companies, they flew me out to Sydney like for a weekend where you go meet their company, you go meet what they do, you go hang out with the people that work there, you learn a little bit more about like their culture, you get absolutely treated. That's what we went to the Crown one night in Sydney and got absolutely spoiled at the cocktail bar with so much sushi. And we got donuts one day, and those were in the lobby of the place that I went to go visit, and they were like golden donuts. I've never seen that in my life. It was so cool. And then the place I interned at the summer had a life-size rink, ice skating rink, like in their office. They had it installed for their Christmas party. And that was crazy because I walk in and there's just like ice skates everywhere, and that's just another day at work. So that is what the coolest part of software is. It's, yes, you work hard, but you play hard too. There are so many exciting things, and this is just the start of even more epic things out there at software companies and thereafter. So I hope that convinced you, and if it didn't, then I hope you do engineering anyways. Thank you so much.
Awesome. Thank you so much, Arushi. Next up, we have our ChemMat engineers.
Hi everyone, my name is Azura, and today I'll be talking to you about chemical and materials engineering. So I'm in my 4th and final year, which means I've only got a couple more weeks of uni and education as a whole left, which is both scary and exciting. And I went to Epsom Girls Grammar for high school. So just a little bit about why I chose engineering. So I enjoyed chemistry and I kind of enjoyed physics in high school. I wasn't very good at it, but I did like seeing how the science that I was learning could be applied to real life, larger scale problems. And then I also knew that if I picked engineering, I could put off being indecisive for another year because your first year is general and you only pick your specialization at the end of that year. And like we're showcasing to you guys today, there's so many specialization options that you can pick from. So yeah, I'll move on. Yeah, I should know how to do that. I'm an engineer. But yeah, so just a bit about what chemical engineering actually is. So I'd say the name chemical and materials is a little bit misleading. It's about 80% process and 20% materials. So what I mean by process is you're designing and optimizing processes to make products efficiently and sustainably, whether that's water, food, energy, pharmaceuticals, or fuels. So it's less chemistry and more about scaling up lab processes to industry. So just to give you an example of that, if we think about white sugar, which we all know and love, and this is actually made, like it's refined from raw sugar to the white sugar that you have in the supermarkets. And this is done at a sugar refinery. So this is a photo of the Chelsea Sugar Refinery in Auckland. So a chemical engineer would be heavily involved in this process. So what a chemical engineer would have done is design this process by creating like a block flow diagram where you sort of look at what goes in and all the little unit operations and all the materials that are required to get from that raw sugar to the white refined sugar. So it's sort of designing and optimizing that process and then transforming that into, sorry, this looks a little bit scary. It's a process flow diagram, which has all the equipment and basically so that we can pass on this information to like a mechanical engineer that would actually build the process, if that makes sense. And then on the material side, ChemMat is about creating and improving materials. So things like plastics, coatings, metals, biomaterials, where the goal is to design materials with new or better properties, whether that's for construction, electronics, or medical devices. And then in terms of careers, I've put a little bit of some of the industries that you can go into, whether that's water, food, energy, or materials. And then the roles that you could have would be like a process or operations engineer. You can go into project management and consulting. And you'll realize as the speakers go on, like project management and consulting is quite common across all engineering disciplines because you have those problem-solving skills to be able to do that. And then there's also a lot of opportunities for further research in ChemMat because there's a lot that I'd say there's a lot more research going into creating more efficient and sustainable processes. So there's definitely a lot of room for research. But yeah, sorry, this is a very heavy slide, but I thought I'd share what ChemMat at UOA looks like. So in terms of coursework, there's lectures, labs, field trips. So in my third year, you get to go to a methanol plant in Taranaki, which is like a 3-day trip with the rest of your class. And it's pretty awesome because you actually get to go to a plant and see how that works. And it's a great bonding experience as well. And then some of the topics that you cover throughout your degree, which probably mean nothing to you at the moment, are like mass and energy balances, thermodynamics, fluid mechanics. You do a bit of materials, some reactor engineering. And my favorite part about ChemMat is it's quite a small cohort. It's like 40-ish students. And so it's kind of like high school where you get to have the same class for a while. And then we have the best split of girls. So there's a lot of girls in ChemMat, which makes it a really wholesome and supportive environment. And you also do a lot of projects throughout your degree, but I thought I'd touch on the stuff that I'm working on in my final year, so this year. So you do like a full year research project and a full year design project. So for research, I'm working on extracting valuable compounds from New Zealand seaweed using green or sustainable solvents. So these are compounds that are helpful to human health. And then for our design project, which is a group project, we're working on designing a process to to make hydrogen from industrial waste, so wood waste. So these projects do probably sound quite different to you guys, but what I'd say links them is chemical materials engineering's like the focus on designing processes, whether that's cleaner ways to extract compounds or producing sustainable fuels. And then in terms of internships, so I've done an internship at Fisher & Paykel Healthcare as well as like Zoe has, but I was working in the injection molding team. So we were creating plastic parts for one of the humidification systems, which helps patients breathe safely in hospital. And then last summer, and I'm currently working at Watercare, where I got to work at an actual water treatment plant, so learn about that water treatment process as well as work on projects at the plant. And obviously, I've already picked this degree, but these internships did solidify my decision because I got to see the role that chemical engineering plays in the industry and providing key life sources. So water, food, and energy are really big industries in ChemMat. So it feels pretty fulfilling to know that the degree that I'm doing, I can be a small part in creating a better future and helping others. So yeah, that's me. Thank you guys for listening.
Awesome, thank you so much. This is just a quick reminder that if you have any questions while our lovely speakers are talking, just pop them on the Slido and we'll get to them at the end during our Q&A session. So at the moment we don't have any questions, but definitely keep that going. And we'll have our next speaker for civil.
Thank you. Is this the last? Okay. Okay. Hey guys, my name is Mia. I am a Part 4 civil engineering student at the University of Auckland, so I'm in my final year. A bit about me. My high school, I went to Avondale College. Is there anybody from Avondale here? Okay, no. And then I went into first year in 2022, and then I decided to do civil mainly because civil deals with very large-scale projects that impact pretty much everybody who is a human. And I wanted to impact as many people as I could with my work and be able to see the culmination of my work in the community. So that's why I chose civil. And also, when you do your first year courses, you get a taste of all the specializations. And I did a bit of coding, I did a bit of CAD design work, and then I realized that I really didn't like it. This is my cheese tablet stand that I made for CAD in my first year, and it took me 3 days, and it didn't really work very well. So that really put me off those specializations. So I went into civil, and then in my second year, at the end of that, I did an internship at a company called Becker. That's the only internship that I've done. Usually people do 2 throughout their degree, but I've only done 1. And then last year I took a semester abroad and then came back this year, and now I have a job, thank goodness, for next year. But about me, yeah. What is civil engineering? So from the word civil, you can probably tell, like, same word as civilians. It's basically anything that designs, a specialization where you're designing, constructing, and maintaining the built environment. So the built environment usually refers to a bit of like buildings, but mostly what we call infrastructure, which is your roads, your ground, your bridges, water systems, and pipe networks. All of the essential stuff that people need to go about their daily lives. This is what civil engineers do. So by transport, I mean like your highways, but also transport networks, public transport networks. How do we go about making our buses and trains reliable and safe and efficient for people to use? Also, we have a subdiscipline called geotechnical, which specializes in ground stuff. So whenever you're building a road or a building, you always need to lay the foundations before you build anything above ground, and it's really important to consider what goes on underground before you do anything above ground. So geotechnical engineers deal with all the soil. Environmental engineers think about how, I guess, whatever you're building, how it impacts people and the environment. So that'll be your like ecosystems, your water quality, all of that, but also how it impacts different people within society. For example, is your project going to impact disabled people more than able-bodied people, or is it going to align with what Māori have in terms of their values and aspirations for the environment? So environmental engineers do that sort of stuff, and then you could also go into the water sector, which deals with pipelines. We have stormwater engineers who deal with rainwater and where to direct the rainwater when you have a lot of rain falling so that it doesn't flood. You also have wastewater engineers who deal with your water that comes from your toilets and showers at home, and then how to deal with coastal flooding, especially in this age of climate change when sea level is rising and a lot of people who live near the coast could be impacted by flooding. How do we mitigate that risk? And then you could also go into construction management, which is purely dealing with cost and time of any sort of construction project and keeping all of it under budget and within time. So very broad range of work that you could do as a civil engineer. In terms of what you actually do at UOA, these are some snapshots from my degree. So going back to geotechnical engineering, this is a lab that I did where they show you how a foundation would sink under soil liquefaction. So soil liquefaction happens in an earthquake when the ground shakes and then all the water comes up, and then it leads to things above ground sinking into the soil. So we got a demo of that. You also get to make concrete. One thing about civil engineers, we love concrete. So you get to learn how to optimize the mix of your concrete so that it's the most efficient and strong, I guess. And then you also get to make a mock pipe network so that you can like learn how to distribute the water to different points within the network. I think you guys do this in one of the WEN events that we do for high schoolers. And then you also get to treat some water. So this is simulating what a wastewater engineer would do, I believe. So this is how much chemical you add to treat the water, and how much mixing you do with the chemical, and how that impacts how clean it ends up at the end. And then structures, we also touch on that a little bit. I think Sonia's going to go into detail about structural engineers, but civil engineers also get a bit of a taster for structural engineering. So this is a beam that you get to make, and you add supports to the side of it so that it doesn't twist or bend in a weird way. And you also get to make a one-story house frame. This is environmental engineering. You get to go out onto Simon Street and measure the noise and air pollution levels based on the number of cars that drive past on the road. And you also get to go out onto the field being the Auckland domain, and you get to measure out the outline of a building and make points on the ground and simulate what a surveyor would do, which is another career path that you could go down as a civil engineer. But yeah, basically what I'm trying to say is there's a variety of courses and a variety of career paths that you could go down as a civil engineer. In terms of the uni experience, I would say it is the largest cohort within engineering. So there are a lot of girls as well, probably not as many as Chem Mat, unfortunately. But yeah, and our lecturers are very friendly and knowledgeable and approachable, so that's always great. And with careers, you can always go down a typical consulting path, or you can go down a contracting path, which is more hands-on and being on site, kind of like a tradie, but a little bit glorified. And then you can also do lab work, or you can be a project manager as usual. There's a range of work that you could do there. And I think one thing that really drew me into civil engineering was, as I mentioned before, the large scale of work that you're doing, but also as someone who really, really cares about the environment and sustainability, I feel like it's a degree where you can directly make an impact to a lot of people's lives. And you can, I guess, address climate change impacts in a more tangible way that you can see out in the community. And you can probably take your career more globally because civil engineers are needed literally anywhere in the world. So, yeah, that's a bit about civil engineering, a bit about me. If you have any questions, go crazy in the Q&A. Thank you.
All right, next up we have Sonia, who will come and speak about structural engineering.
Hi guys. Hey guys. So I'm Sonia. I'm gonna kind of speed run this because we're kind of short on time. But yeah, Mia already did a great intro on civil structural engineering, sort of the same. But I'm from Westlake Girls High School. Can I just out of interest, who's here from Westlake Girls High School? Can I get a Slay? Yes, Ella. But yeah, I basically wanted to do architecture for the longest time. I actually came to one of these events in 2022. Did sit on architecture, got dragged along by Ella in the back, and I changed my mind. And let me tell you why. I wanted to do architecture because I kind of really wanted to build stuff. I really like buildings, duh. And I actually figured out that my idea of architecture was sort of what I would do as an engineer. Basically, how this building is going to stand, how it's going to withstand the forces, the loads. And basically, I told myself, gonna go to engineering in UOA, gonna do civil engineering, and figured out, actually, there's a spec called structural. Yeah. So you may be wondering, what's the difference between structural and civil? Mia already did a great intro on that. Basically, it's an umbrella term. Structural is one of the specs that civil engineering offers. But in 2020, UOA decided to sort of introduce it as a specific, a different spec, Reason for that being, New Zealand is an earthquake-prone country. As you can tell, we have a lot of earthquakes happening, and we're quite seismic. And for that specific reason, we do need engineers that are specifically trained in structural engineering. And the difference in that course-wise is Part 2, Civil and Structural, we take the same courses as Mio introduced. It's in Part 3 and Part 4, basically, that it separates. So structural engineers, we do focus a lot on the main 3 materials, which are concrete, timber, and steel. And also we have a course for structural dynamics, which obviously because earthquakes. And with the career path in structural engineering, specifically now that it's a separate degree, they do look more for people who specifically have done a structural engineering degree if you do want to do structural projects. And yeah. And I probably should have included this at the beginning, but this is me, guys. Hi. In the middle, this is a bit of me studying structural engineering. That's me holding a little beam because our lecturer does really like handing out like samples and everything. My labs are really cool. I do really love my degree, specifically because, again, I do really like buildings. I'm a bit of a nerd. I really do like earthquakes, do really want to do a project in seismic in Part 4. And on the left is my internship. I interned in CB Civil. It wasn't really a structural internship. It was a 3 waters internship. But one thing interesting about civil engineering is that's the beauty of civil engineering is that you will have basically every single spec kind of involved. And the structural aspect of this project was sort of a palisade wall. A palisade wall is basically when you dig into the ground, you're going to need sort of like a support for this there's 8 meters, 5 meters of excavation. You do not want that dirt to fall down. So you do a lot of concrete pouring, planning this entire wall out. Structural engineers get into that. And on the right, engineers do other things than studying engineering. I'm in WIN, and I'm also in Engineering Review, which is a theater show. You guys should come. And yeah. That's a bit about me. Gonna need to speed run this a lot, but definitely if you have any questions about structural engineering, the differences, what we get up to, pop it in the Slido, and you can talk to me after this event as well. Thanks, guys.
Next up, we've got Veronique to talk about mechanical engineering. I always think it's me in this photo, but it's not. Hi, everyone. I'm Veronique, and I am a 4th-year mechanical engineering student at Auckland. As Sonia said, I'm going to keep this really brief. If you have any more specific questions, you can chat to me after or pop it in the Slido, and I'll do my best to try and answer those for you. This is my life outside of uni. I'm a very big family person. I love the beach. I love to travel. I love Taylor Swift so much I flew to Australia twice to see her. And another big part of my life is last year I spent a semester abroad like Mio in Canada doing mechanical engineering there in Vancouver, which was the time of my life. So I couldn't speak about my university journey without showing you pictures from me hiking the snow in my weekends and telling you that that is an opportunity you can have if you come to the University of Auckland. We've got hundreds of places you can go to, and you can do engineering there too. So a brief little backstory on how I got into engineering and why I chose mechanical. Kind of similar to a lot of girls here, I didn't choose engineering. I came to university and I did a year of biomed in my attempt to try get into med. I realized very quickly it wasn't for me, and I came back in 2nd year and completely restarted and went into my 1st year of engineering. And at the end of that year, I realized that I was a pretty competitive person, and I wanted to join a spec that had a large amount of boys, very little girls, and prove that I was better than all the guys in that spec. So I chose mechanical engineering. What is mechanical engineering? It is basically, in the large sense, anything that moves. So if anyone took a car to get here tonight, or a bus, or a train, you used mechanical engineering. Anything you own in your life that moves had a mechanical engineer work on it.
And so really it is so broad and it impacts your life in so many ways that, yeah, it's just impossible to really draw the scope around what mechanical engineering is. And these are the projects that I've done in mechanical engineering at uni. Some people will tell you their spec has the most projects, but I'm here to tell you I think mechanical has the most projects. And they're a little tricky because they just say, here's the brief, do whatever you want, and they give you 6 to 12 weeks, you work on something all semester, and then you rock up to class with a pink-themed car in a spec full of men, and they tell you that your car is the best. We designed a marble run, we designed a kite. This is a bracket that would go in a plane, hopefully not a Boeing plane, but you know, with my engineering it might be in a Boeing plane. And finally, my 4th year project, which is in your last year of engineering, you work on something all year. And I'm focusing on snapping carbon fiber, but specifically carbon fiber that makes large structures such as foiling ferries, which, if you're like me and live on the shore, I take the ferry quite often. And so to make them faster and more efficient, I'd love to be able to use my research one day. So what can a career in mechanical engineering promise you? I wish I could promise you and sell you the dream of Formula One, and if you do mechanical engineering, it's a very likely possibility that you can be part of that world one day. You can design planes. You can also design buildings. All the air that's rushing in and out of this room right now was designed by a mechanical engineer because air moves. And so I really think it's very broad and open-ended. There's so many amazing opportunities that you can do. You can travel around the world with mechanical engineering, and it's very easy to see the tangible effects of your engineering when you watch the cars race around the track every week, or you fly on that plane to go on your holiday. And I'm really excited that that is where the future of mechanical engineering is going, improving things like this and just really making amazing advancements. Yeah, and I'm going to work at Becker next year, which is one of the amazing companies that offers mechanical engineering. So yeah, any questions, feel free to ask, but otherwise, I truly love mechanical engineering. I think it's the best. So yeah, and now I'm going to hand it over.
Awesome. Thank you so much, Veronique. Big fan of the Barbie car, by the way. I know someone in my tutorial also did that. So big fan, guys. Women in STEM, we can do a lot of creative things and show the men up. But next off, we have Mechatronics Engineering, my favorite. And we have Ria to present us about the spec.
All right. Hi, everyone. I'm Ria. Final year doing Mechatronics Engineering. So before we jump on to what Mechatronics Engineering what it exactly is, a lot about myself. I love reading books, but I haven't made a bookshelf because I want to make it myself, and I keep stacking books in the corners of my room, and I'm running out of space now, so now's the time that I actually make it. I've also started a little hobby of trying new sports every day. So it's not badminton exactly. I do tennis, badminton, so different sports every week. So I touch grass and not study all day long. I love doing puzzles, love coffee, and if you go through my gallery, I'll have hundreds and tons of pictures of pretty skies, colorful skies, different pictures of clouds. Easy. So the past, let's say, 3.5, 4 years, so first year was general year, so that was a little bit about, I was getting a little hint about what I'll be getting into. So what basically mechatronics engineering is, it's an interdisciplinary field where you learn about electronics, software, and mechanical as well. So you don't get stuck doing one thing at all. So after your first year, you start doing. Your second year is more focused on designing things, third year is more software and electronic based, and then fourth year, whatever you like. If you want to do more space stuff, go into that. If you like doing more mechanical stuff, there's more design papers for you. So I've got a few pictures here where you can see I've got lots of chance of networking with people. You'll see a few silly pictures of me and my friends in our labs trying to work around our projects after working for like 4 hours, and then at the end of the day we're just being silly because you know what, at least they make us laugh. You'll see lots of 3D printing going on. That's something I really enjoy doing. And from these past 3 years, I've learned one thing, that having a workstation is quite important. So if you look at the top right, you'll see my desk at home, which I'm have gradually maintained for 3 years now, and working on that actually makes a lot of difference. And then you also get to do internships over the course of your degree. But yeah, with Mechatronics, you can honestly go anywhere you like. If you don't want to do engineering jobs after you've done your degree, feel free to go with that. You have lots of options there as well. But Mechatronics engineering discipline-wise, you get to do robotics, and you get to be a robotics engineer, automation engineer, optimization engineer, a real-time systems engineer, which I have been working as for my internships and love doing that. And then if you enjoy what you're doing, you can always go and research more about it. You can study more about it and make new products. At the end of the day, engineering, the reason why I took engineering was because how open it was, and it did not let me be into like, you have to do one thing. I'm open, I can go anywhere I like, which is one reason I took engineering. And then you've got tons of companies that you can intern with, work with, network with, so many like-minded, smart people, and there'll never be a day where you won't learn anything. So take engineering, guys. It's actually quite fun.
Right, last up we have Anahira to talk about biomedical engineering and insight.
Right, hi everyone, I'm Anahira and I'm in my 3rd year of biomedical engineering. Cool, so I'll try and keep it really brief, but a little thing about me, I've got a lot of hobbies, and the good thing about uni is that there's a lot of different clubs that you can join to really just actually do everything that you like to do in your free time. Cool, so a lot of the time people don't really know what biomedical engineering actually is, and I was definitely one of those people as well. But I'll give you guys a really brief overview. So it's kind of like the intersection of software, biology, mechatronics as well, and electronics. So it's kind of just the intersection of all of these different specializations, and you get to use every single thing to kind of work on systems that help with relating to the human body, basically. So a big thing about biomedical engineering is that the different things that you can go into are usually always focused on actually making an impact in people's lives. So as you can see over here, there's a lot of different projects that you can work on, and a lot of these are relating to electronics and bringing in some coding as well to work on those medical systems. And I'm really happy to speak with you guys after as well to talk a bit more about these. Yeah, so what can you actually go into with biomedical engineering as well? I feel like this is something that a lot of people also don't know, that there's so much that you can do with biomedical engineering. And so you can go into basically all of the different companies that people have mentioned earlier today. You can go into all of those, and you also have the option to go into research as well, which is quite interesting, because if you're someone who's interested in science as well and isn't too sure, are you into science or are you into engineering, that's a good thing about biomedical engineering, is that you really do just have all these options that you can follow, and you can kind of go into anywhere that you decide to go into. Yeah, so I'm really happy to speak with any of you guys after as well, and feel free to ask more questions in the Slido. But yeah, cool, that's me.
Hey everyone, my name is Siying and thank you for sticking around. So this is our 10th and final spec of the evening. So I am a 4th year engineering science student, and when I'm not studying, these are all my hobbies. And so yes, in high school, I took a range of different subjects. You have the sciences, you have the music, and also classical studies. And I was someone who always wanted to work in tech. I thought that was such a cool idea. But also at the same time, I had a lot of hobbies and interests, and I didn't know what to do with my life. So for uni, I obviously wanted to take a degree that can make me procrastinate choosing what I want to do with my life for a bit longer. And naturally, engineering was such a good option because in the first year, you explore all of the different specializations, and by the end of it, I really enjoyed the coding and the maths paper, and that led me to choose engineering science. So what is engineering science? You may think like this probably doesn't really explain anything, right? So engineering science is a degree, is a major that is offered here at the University of Auckland only, and it basically offers 3 main aspects. So the first one is operations research, and simply put, this optimization. So for example, if you have a set of locations for a truck to deliver to, how can you optimize the path of this truck so that you can save the most fuel and you can save the most time? And secondly, data analytics. So we are living in a world with so much data, little pieces here and there. How can we kind of draw this big picture of all these little pieces so that it tells us a story and it tells us how we should move forward with our decision making? And thirdly is the computational mechanics component. So this is kind of basically speaking to how the real world works. So for example, if you have a plane, so this is my final year capstone project over here. So we built this with our bare hands. It was actually quite tough. But we basically go from the start to end where we model how the air works and how the material behaves and how they interact with each other. So we model the processes as well as, for example, over here, how the wind blows and how this interacts with the airplane wings and how can we optimize this process. So it's like how all these components working together to optimize a system that we have. So yes, that is engineering science in a nutshell. And so yes, life as an eng sci is quite fun. I think as soon as you get into your specialization, we hop into a field trip with the biomedical engineering students where we go to Rotorua and Taupo for 3 days, I think, or 2 days, can't remember. But yeah, we basically just meet a bunch of cool people and chill, and you all obviously have all these really fun win events. So when you're not studying, and also when you're hungry and starving, there's definitely always free food waiting for you. And yeah, so what does an Eng do out of uni? So honestly, literally everything. Like I have seen over this past summer, I have friends who were working on site as a geothermal engineer. I have friends who are in the labs doing research. And myself, I was working at a tech company. So I worked at Spark and TradeMe. And I think one thing that is really nice about engineering science is that it's a really nice gateway to help you go into tech. And it also kind of keep the options open up for you. So yeah, like I think at Spark, I really loved what I loved about working at tech companies is, like Arushi mentioned, is the perks. Like we had our Christmas party at the Spark Arena, and at TradeMe, oh gosh, every morning you can see a whole line of men just lining up to go down the slides from level 3 to level 1, and it was a life-size slide. And so yeah, it's just like really fun perks like this, as well as the work as well. We do a lot of different real like fast-paced but also meaningful work inside the company, and you get to contribute that even just as an intern or as a fresh grad. So yeah, that is engineering science, and if there are any questions, I'm happy to answer. So yes, drop it into the Q&A. Hand it back over. Thank you, everyone.
All right, so we'll go into our Q&A panel now. So we'll have our lovely panellists come up to the front and get ready to answer some of your questions. Just while they're getting ready, a question that has come up is how big are the different specialisations? So this is very dependent on the availability and kind of the demand for each specialisation. So it varies year to year. Generally, civil, structural and mechanical are the biggest specialisation cohorts, but it depends on if how many people in each year want to pursue each cohort. So it is really variant, but if you are interested in those numbers, you can have a look on the University of Auckland Engineering website to see the number of intake per year for every year. Awesome.
Okay, so we'll jump right into our first question. So, for anyone that would like to answer, is there an easy way to make friends in your specialisation?
Go to WIN events. No, but really, yeah.
Yeah, I definitely think going to different club events is the way to go. And yeah, again, depending on your specialization size as well, I think, for example, biomedical engineering, there's like 20 people in my year, so it's really easy to make friends.
On top of that, really depends on, because personally I was in first year halls. Also, join other clubs, like obviously WIN is really good. You are going to have, your spec is going to have their own club, like Student Society. How many times am I going to mention review, guys? Join different clubs, you will find friends. And at the end of the day, as long as you put yourself out there, they're definitely like-minded people, and you're going to make amazing friends. Yeah. Are we going to pass this down? Is it like a conga line?
All right, we'll just quickly move on to the next question so we can get through as many as possible. Maybe for mechanical or civil, but what is the ratio of hands-on work to work with lots of writing and documentation?
Do you want to go first?
So you take 4 papers a semester generally, and I would say one of those is generally mathematics based. One of them will be projects based, but when you're doing the projects, I'd say it's probably 50-50 in terms of hands-on work and then writing. So every time you do a hands-on, produce something physical, you have to put a technical report behind it. But actually it's not that much writing, and it's generally always group work. So it's not too bad.
Awesome. So wherever you go, guys, you won't be able to escape English or writing. So just a reminder for that. So our next question is, what support is there from the faculty if you're struggling to choose a specialization in your first year?
So the faculty organizes, or is starting this year, is going to organize a spec fair thing. So basically, each of the specializations will have a little stand up, and you can go around and talk to people and learn a bit more about them. So you'll be able to talk to students as well as faculty members. So there is definitely lots of stuff you can do.
Just a general question. Have any of you ever felt outnumbered as a woman in engineering, and how have you dealt with that?
For my internship, I was the only woman on site. It definitely was an experience. Again, it didn't stop me from making friends on site. The people there were lovely, but to be honest, it also was sort of like an empowering moment for me as well, to know that, yes, I am the only woman on site, but I am kind of that gateway into bringing diversity on site, bringing diversity to my degree, to my job. So yeah, at the end of the day, don't let limitations like this stop you. Engineering is for you as long as you like it, as long as you have a passion for it, go for it. Yeah.
Awesome. So we also had a question on the space sector. So can engineering lead to the space sector, and what specializations lead to that?
I can take that. Okay. Can you guys hear me? Okay. So in your fourth year, when you're doing engineering, you get to choose a lot of electives. And when you do mechatronics, you have an option of choosing space papers at the end of it. I myself am doing a space-based research project for my fourth year, which is basically collision avoidance in space. So if you do, so in your fourth year is basically where you want to go as to see what your interests lie. There's also different clubs at uni, like the Space. I think it's called the Space Hub, and we've also got a Space Hub where they launch rockets. They launched a rocket, I think, last month. Yeah, was it last month? Okay, yeah. They launched a rocket last month with partnership with Rocket Lab, so it's quite interesting. So once, so your pathway would be take space papers in your fourth year, and then from there you can do a fourth year research paper based on space, and then from there aerospace or aeronautical masters that will take you through there.
Yeah, sorry. I also just wanted to add on that. I forgot to mention in my presentation, this is what happens when you don't make notes, that Rocket Lab, which is a world-leading space company, it founded, still builds in New Zealand, has an incredible relationship with the University of Auckland. They actually test a lot of their stuff on our Newmarket campus. And mechanical or mechatronics, those are the two specialisations that lead you directly to jobs at Rocket Lab. I actually lost count of the number of friends I have who are now got graduate jobs at Rocket Lab. They pay really well. The opportunities are really endless. So if you're really into space, mechanical and mechatronics is the way to go. And the University of Auckland really helps get you there. We have Rocket Lab on site all the time, and that is really cool.
Awesome. If you guys could go back and give your high school self a piece of advice, what would it be?
I would say, don't be afraid to try something. If you think, of the possibilities that you could achieve if you just think, I can do it, I can give it a go. And just put your best effort in it as well, because, you don't really know how good you'd be at something unless you try it. So just try it, and you can see, the outcome when you give it your best shot. And in terms of, a few of us who initially, started off with a different degree, and then we went into engineering, that's absolutely okay. It's so acceptable. I think a lot of the time, people are like, oh, you have to know exactly what you're doing, but there's no such thing. I changed, Arushi changed, and a few other people changed, and that's totally okay. You're not meant to know exactly what you need to do, so just give it a go, is what I'd say.
Awesome. I think that's really good advice for everyone here who's considering what they want to do for next year. We also had quite a few questions regarding internships. So if someone would like to explain what exactly are internships and how do you get an internship?
So you are required when you are doing an engineering degree here to do 800 practical hours, and that's a component that you have to achieve for graduation. Now, that sounds really intimidating, but the intention behind that is that you have 2 summers worth of work, so one summer would be 400 hours, and that is a way for you to get a job after you graduate. And it's actually a really good way for the university to basically say, hey, okay, just do 2 summers worth of work. We'll help you find something as much as we can, and you can try find something yourself. And then usually I'd say most students end up going back to a company that they interned with. And that's just a way, a segue into you getting a graduate role. And companies prefer having you as an intern and then having you return back as a grad. Because for you, you get to, it's like a low commitment summer relationship where you just figure out if it works or not. And then for companies, they can see if you're a good fit. Is the work what you expected? Are you doing well? So that's what it is. It sounds like a lot, but it's really there for the best. And there is so much support for you to get there. so that you can make it happen. Like, we have practical workshops all the time, which is the network that you're automatically part of if you are a woman at this university in this faculty. We have 18 amazing sponsors who are actively recruiting all the time, and you get first preference when it comes to interviewing and everything if you get in early as well. We have a million career expos. I cannot count the amount of times I've come in and there's been like lines of companies around. So like there is like every opportunity for you to get an internship if you just try. That's pretty much what it is. And I can't think of anyone that has struggled to fulfill that graduate component. Like, I don't think people, like, if you don't have a summer of an internship, you generally go back as a grad and then you can continue and fulfill those hours. But it's not like you just never graduate, ever. Like, you will graduate at some point.
Awesome. Just in the interest of time, I think we'll wrap up the panel Q&A here, but feel free when we have dinner out in a couple moments to come up to any of the girls here and just ask us any more questions about specialisations or engineering in general. But just to reiterate our main points from this evening, the first year of engineering is general, so you get a bit of time, you get a whole year and a whole year's worth of courses to decide what you like and what you want to go into, so you don't need to feel pressured to know exactly what you want to do right now. And if you're here because you're definitely sure you want to do engineering, we're really excited and lucky to have you. But if you're one of those on the fence, as many of us were initially, we encourage you to keep coming along to these events and finding out more about what engineering actually is in a practical sense, because it's very different to at least what I thought it was in high school and many of us did. So keep finding out more, keep speaking to us, and we're just really lucky to have you and hopefully join you coming up in our future years as future engineering students and members of the Women in Engineering Network, if you so wish. But yeah, that's all from me. If you want to stay in touch with us, we have our socials, so feel free to follow us on all of our socials and we'll post any more events that we have coming up. But we'll have dinner out shortly, so feel free to help yourself to some food and come up and have some chats with us. Thank you very much for coming. So if you just head out up the stairs, there will be food as you see, just as you exit the lecture theatre. Thank you.